This is Flip-Flops video 4, and in this video we're going to show you how to build a clocked RS. Okay, as with all of our circuits, we're attempting to combine and apply the theory that we've learned with these flip-flops by making actual circuits. And then we're going to test them, and we're going to test them using the truth tables. So what I'd like you to do first is complete the waveform on the sheet that was handed out. And secondly, I want you to construct the circuit that you see below you using two LEDs, just like you did with the RS, as the outputs. So the green LED represents Q, and the red LED represents Q naught. You'll notice with this circuit we have two additional NAND gates, and it's tied to that clock pulse. So you should use your logic and your knowledge of logic and NAND gates to determine why that is built that way, and it should make sense to you as you look through some examples with the truth table. So the question becomes, what are you going to use as a clock for this circuit? Okay, the way that we're going to build our clock is using the 555 timer. We've built that before in grade 10 if you took grade 10. And this is the circuit here. It's quite a simple one. It's the 555 timer, the 8-pin IC that you see right here, with an LED and a resistor that comes out of pin 3, which is where that pulse train is generated. Comes right out of pin 3. So when you're wiring pin 3 to your flip-flop, you don't want to go through the other side or the negative side of this LED, because then you're going through the LED. You have to wire it in parallel from this pin 3, because that's what generates the pulse, and we don't want to have a voltage drop here over this LED. You can see 4 and 8 go to positive, pin 1 goes to negative here, 5, ignore that, and 1 goes from positive right to pin 7. The two components which are really in charge or in control of the speed of the flashing are these two right here. This electrolytic cap, which we can start at 10 microfarads, and this resistor at 100, which control how fast, okay, this resistor controls how fast this cap gets charged. So the higher the resistor, well, the slower this is going to get charged, therefore it'll slow the flashing down. Likewise, if this cap is larger, it's going to take longer to charge, and thus slowing down the frequency. So we want that. We want actually a pretty slow frequency. You want to have one pulse maybe every 3 or say 4 seconds. Okay, so one pulse every 4 seconds. Okay, so once you build this, wire it directly to your flip-flop, and then we're going to test it against the truth table to ensure that this part of it works. Okay, we're not so much interested in the prohibited state because we're never going to use it, but you want to test your circuit against this truth table. And specifically, I want you to focus on what I've got here on this bullet here to the right, is that change your inputs in between the clock pulses. So go from a set state to a reset state in between the clock pulse, and see if you notice there should be no change until that clock pulse occurs. Okay, and that's how you know that you built it correctly. Okay, so have fun building the circuit, and this concludes the video.